Hello, my name is Isabella and I will be your host today for another mathematics video brought to you by RJ. My question for you today is, what is the smallest number that is divisible by all consecutive natural numbers up to n? We might guess the answer is n factorial. This makes sense since n factorial is divisible by 1, 2, 3, and so on. However, n factorial may not be the smallest number that is divisible by all consecutive natural numbers up to n because there may be natural numbers in that set that share certain numbers in their prime factorization, such as 2, 3, 5, and so on. We have to account for these shared numbers. How do we do that? Let us focus on a particular prime. Let's call it p. Clearly, any multiple of p shares one p in common with p. So, we just need to calculate how many multiples of p there are in n. We can do so by this formula. The floor bars are here because n may not be a multiple of p, and we want the greatest integer of n divided by p. We subtract 1 because we are comparing p with every other natural number in the set. In other words, we are not comparing p with itself, so we need 1 less. Is that all? Not quite. We also have to consider all the powers of p. Even though we considered all the multiples of p, there may be extra copies of p lurking in the midst of the set, specifically in the powers of p. We need to calculate how many of these extra copies of p there are. The easiest way to do this is to determine the amount of extra copies of p there are in the greatest power of p in the set. Here's the formula to do so. The floor bars are here because, again, n may not be a power of p, and we want the greatest integer of log base p of n. We subtract 2 because we already accounted for the power of p is a multiple of p, which subtracts 1, and again, we are comparing p with the greatest power of p in the set. So we need 1 less, totaling to 2 less. But this is just the extra copies of p in the greatest power of p. We need the total amount of extra copies of p in the entire set. Since each power increases consecutively, then so does the amount of copies of p there are in each power of p. Therefore, we can use the closed formula for the sum of consecutive natural numbers to figure this out. Now we have all we need. We have accounted for all the shared p's. We just need to add these two together. I'll leave it to you to do the algebra, but I'll show you the result. Here is the best simplification of their sum. Keep in mind, this is just the amount of shared p's. We now need the value of when we multiply them all out. To do so, we just make this an exponent with base p. Remember, we focused on a particular p. We need to consider all primes. This is a product of all the shared primes in all consecutive natural numbers up to n. Blackboard p is the set of all primes. Unfortunately, as of yet, we do not have a formula that tells us whether or not a certain natural number is prime. All we know is a prime is a natural number whose only factors are 1 and itself. Thus, this is the simplest way to represent the product of all the shared primes in all consecutive natural numbers up to n. In the beginning of this video, we guessed that the smallest number that is divisible by all consecutive natural numbers up to n is n factorial. We just need to divide that by this. This is our answer. This is the smallest number that is divisible by all consecutive natural numbers up to n. I encourage you to try a few numbers for n. Of course, when n is large, this may be a bit difficult since the amount of primes increases as n increases. I leave you with 2 questions. How would this formula be different if we had an arbitrary natural number as a starting point? Or if the natural numbers in the set were not consecutive? I hope you enjoyed the video. Thank you for watching.